Hello, I'm Dr. Karen with Embrace Life Ohm and Mother Core, and this is our continuing series on light and your health. In an earlier episode of our series, Part 3, The Hidden Hazards of Energy-Efficient Light Bulbs, we talked about the scientific observation that blue light causes oxidative stress in your body. And to understand what oxidative stress is, I encourage you to go back and watch Part 3 if you haven't already done so. In Part 3, when I talked about the oxidative stress, I promised to explain the physical mechanisms of that in a later show, and this is that show. I'll be talking about how blue light causes oxidative stress, but I don't just want to make blue light out to be a villain, because it's not. It does so many things in our body which are absolutely critical to our health. So in addition to talking about the oxidative stress, I'm going to give you a whole overview of how blue light works in your body. So before talking about blue light specifically, I want to talk about how is light absorbed in your body. So basically anything that has color, which includes anything in your body that has visible color, has that color, of course, because it's absorbing light in the visible wavelengths and reflecting other wavelengths. So for example, if you look at your blood, which has the color of red, it has that visible color because it's absorbing blue and green and yellow and reflecting the red back to your eyes. So blood absorbs blue because it has something in it called hemoglobin, which carries oxygen in your blood. And hemoglobin has something in it called heme, which is a porphyrin. And a porphyrin is one of the classes of chemicals that absorbs visible light very well. For example, another porphyrin is chlorophyll, which allows photosynthesis in plants. So the heme in your blood is a porphyrin, which absorbs blue light. Now, other things in your body which are very good at absorbing blue light include a class of chemicals called flavins, a class of chemicals called nitrosated proteins, and a class of proteins called opsins. These chemicals and proteins in the body can absorb blue light because they have parts of them called chromophores in which the electrons are arranged just so that when they're hit by the amount of energy in a blue light photon, that amount of energy is exactly what they need to jump to the next electron orbital. And when they do this jump, they energize the entire protein or molecule. When the protein or molecule is energized, a number of different things can happen. They can change geometry because the electrons are in a different orbit. They can speed up whatever they're doing because they have more energy. So if it's an enzyme, they can start producing more of whatever they're producing. The energy can be used to send a signal to someplace else in the body, or the energy might be used for photodissociation. That is, there might be a break in the protein structure. So let's go back to the example of hemoglobin, which, as we said, is very good at absorbing blue light. Hemoglobin is often connected to nitric oxide. When blood is hit by blue light, there's photodissociation between the hemoglobin and the nitric oxide, releasing free nitric oxide into the blood. This free nitric oxide decreases your blood pressure, decreases arterial stiffness, and increases the perfusion of blood into tiny capillaries in the tissue. So the blue light is great for your blood pressure and circulation. So that is an example of photodissociation. But as I said, blue light energy can also be used to increase the production of various chemicals. For example, the energy from blue light hitting our body is used to increase the production of serotonin and dopamine. These chemicals are used for many things in our body, but one of their most well-known uses is to elevate mood. And we know there are some people who get something called seasonal affective disorder, where when there's less blue light during the winter, they feel really sad because they can't make enough serotonin. And these people can be adequately treated by giving them a sun lamp that produces a lot of blue light and allows them to raise their serotonin levels again. At the same time, blue light hitting us disables an enzyme that converts serotonin into melatonin. So during the day, at the same time that the blue light is allowing us to create all this serotonin, it's bringing down our melatonin levels, which is great during the day. However, we need melatonin at night. So while blue light during the day can help decrease depression, Having blue light at night, which decreases melatonin, will put us into a state of oxidative stress and inflammation, which will increase the probability for depression again. So I just want to be clear that although blue light at the right time has an antidepressant effect, you shouldn't expect that blue light to be an antidepressant at night. Now, in addition to causing the timing of different immune system actions in the body, blue light specifically stimulates certain parts of the immune system. And some of the parts that it stimulates are parts that create ROS, or reactive oxygen species, in order to kill pathogens. Now, blue light probably stimulates these particular parts of the immune system because when the sun is up and you're active, you're more likely to be encountering new pathogens. So you're going hunting, you may be getting cuts, you may be coming in contact with people and animals. And this is a time when the immune system wants to have more ROS on hand to fight invaders. However, if this is overstimulated, this is one way in which blue light can contribute to oxidative stress in the body. Blue light also increases oxidative stress by affecting enzymes in the mitochondria and peroxisomes and causing them to create more hydrogen peroxide. Hydrogen peroxide is a potent oxidizer that is used to kill microbial invaders. However, if there's too much of it, it will create oxidative stress in the body. Now, if you're out in natural sunlight, the blue light will be accompanied by red light and near-infrared light. Both of these are antioxidant, as we explain in Part 13 on red and near-infrared light therapy, and this will help to protect you from that extra hydrogen peroxide. You'll also be protected if you have high levels of vitamin C and other antioxidants in your blood. So they found, in fact, that sunlight only increases your risk of macular degeneration from blue light oxidative stress if your levels of vitamin C and other antioxidants are low. However, if you're not in sunlight, if you're under energy efficient lights, these lights tend to have a lot of blue light while having very little red and near infrared. In this case, it's a much stronger oxidative stress on your body, particularly considering findings that the intensity of blue light may not be that important for the amount of oxidative stress, but the duration is important. And that might be because there's only so much these enzymes can be sped up at a time, but if you're speeding up those enzymes for a long period, that could create a lot of cumulative damage. And it's important, though, that blue light doesn't just increase the oxidative stress on our bodies. Through the same mechanism, blue light will increase the oxidative stress in a number of different types of bacteria. Therefore, blue light can be used as an antibiotic, killing bad bacteria on our skin or even inside our bodies and in our bloodstreams, again, since the blood circulates near the skin's surface. There's even been experiments with putting probes into the stomach to put blue light down there to try to kill H. pylori and other problematic bacteria that may be in the stomach. In addition to killing bacteria, blue light can also kill cancer cells. This may seem a bit ironic because the oxidative stress caused by blue light can cause cancer to begin with by causing DNA breakage and mutation. However, once the cancer is present, if the blue light is together with riboflavin or vitamin B2, which captures blue light very effectively, oxidative species can be created, which are very good at killing cancer cells. So blue light plus plenty of riboflavin in the diet may help you to beat cancer. In addition, note that the riboflavin is destroyed in the blue light capture process. So if you're getting a lot of sunlight, which is important for your health, it's also important that your diet be very rich in vitamin B2. As a final topic, I want to talk about blue light and babies. Now, often preterm babies and sometimes full-term babies have too much bilirubin in their blood. Bilirubin is a blood breakdown product, which is usually handled in the liver, but sometimes a baby liver isn't up to the task. But as we noted that blood absorbs blue light very efficiently, bilirubin also absorbs blue light very efficiently, and this blue light for bilirubin is photodissociative. So the blue light breaks the bilirubin down into smaller pieces, which can be easily excreted by the baby. Now, if your baby only has a little bit of excess bilirubin, the doctor might tell a parent to give that baby some sunshine at home. This is great because in the sunshine, the blue light helps with the bilirubin, and you also have the red and the infrared light to take care of the oxidative stress caused by the blue light. In addition, in the sunlight, you have UV light. Now, people often get very scared of UV, but UV has some very important roles in the body. In particular, we talked about blue light stimulating certain parts of the immune system. Now, UV light will unstimulate these same parts of the immune system. So under the blue and the UV light, the immune system will remain balanced. But if you only have the blue light, the immune system can go out of balance. So now let's say that the baby is in the hospital and is under artificial blue lights. The artificial blue lights will not contain much UV and will not contain much red and infrared. In these cases, it has been observed that the baby after that treatment has elevated oxidative stress, elevated DNA damage caused by the oxidative stress, and has their immune system thrown out of balance, such that these babies have a higher risk of asthma in childhood. Unfortunately, too many babies are placed under artificial blue lights because doctors are not apprised of the risks, and they are just too concerned about the bilirubin going to the baby's brains when this is a rare occurrence. It's not that it won't occur, but there are actually higher level tests where you can see if the baby is more vulnerable to that, and we'll include that in the references. So we need to be more careful about putting babies under these blue lights and more willing to put them under natural sunlight, of course in a controlled manner so they don't get burned. At the same time, we need to be more apprised of the general population's vulnerability to the blue light. When we have our artificial blue light exposure indoors, we're increasing our oxidative stress and we're changing the effects on our immune system. We're making ourselves more prone to allergic and autoimmune diseases, as opposed to the natural blue light that we get from the sun, which is balanced. At the same time, when we don't get the optimal amount of blue light in the morning by being indoors, we're messing up our circadian rhythm for the entire day, which also has impacts on our immune system function. So getting the blue light right, this critical part of our health, is really important for our healthy homeostasis. Thank you so much for watching.